Brad Williams, Frugal Finance, determining Treasury zero rates using the bootstrap method. All I'm going to say is this is patience in terms of understanding and patience in working through what it takes to bootstrap in order to price Treasury zero rates using the bootstrap method. Another method for determining Treasury zero rates involves using Treasury bills and coupon-bearing bonds, with the bootstrap method being the most commonly used approach. To demonstrate how this method works, let's consider the data below, which represents the price of 5 bonds. Since the 3 bonds do not pay any coupons, calculate the zero rates corresponding to their maturities. It's straightforward. For instance, let's examine the 3-month bond, which yields a return of 2.5 in 3 months on an initial investment of 97.5. With quarterly compounding, the 3-month zero can be calculated as 4 times 100 minus 97.5 divided by 97.5 equals 10.256% per annum. Alternatively, with continuous compounding, the rate becomes 1 divided by 0.25 times log normal, 1 plus 0.10.256, divide this by 1 divided by 0.25 equals 10.127 per annum. 6-month bond provides a return of 5.1% in 6 months. You go 100 minus 94.9 equals 5.1 on an initial investment of 94.9. Here's your price right here, 94.9. With semi-annual compounding, the 6-month rate is 2 times 5.1 divided by 94.9. Semi-annual compounding is 10.748. 9.49 versus 10.748. With continuous compounding, it becomes 10.469. That looks simple. Why don't we just look at what's going on here? Again, we're going to use the tools that are available. We're not going to try to force this. I have to brute force, and don't do it. Why? Because it's a waste of time. Use the tool. So here we have this 4 times 100 minus 97.5. Divide this by 97.5 equals 10.256. Then we have continuous, which is 4 times log normal, 1 plus 10.256 right here. Divide this by 4 equals 10.127. Here we have this 10.748 semi-annual, 469. The formula for this short-term stuff, simple. We have this bond principal of 100. We have time to maturity. So that's quarter, semi-annual, annual, year and a half, and 2 years. Annual coupon. Here are the 3 examples we're talking about. There's no coupon here. So that means this is a treasury. Treasury, treasury. Then we have these coupons here. But note we're further than that 1 year. What's the bond price? US dollar. This was given 97.5 right here. This 94.9 was given right here. It was given. And then this 90 and the 96 and the 101 are given. So our zero rate with normal compounding is 4 times 100 minus 97.5. Straightforward. Our zero with continuous compounding is 10.13. Here we have 10.748 based on this bond price. We would go back to that treasury. Let's assume those were par pricing. We know we'd have to figure out the price. Then we could use this zero, and then we'd come up with this. We can use continuous or normal, so you can see the difference. And then you're going to see 11.111. We don't have a zero with normal compounding. We have to use continuous compounding, and it's going to equal B52. So I cheated because there's a few extra steps you're going to have to take in order to compute this zero. In the previous example, we had 1 year, 2 year, 3 year, and we had that information. Here, because it's a year and a half, there may be a few challenges. And then the 2 year, we're just going to grab the information. What is the zero rate for a 0.75 year bond? We go 0.05 times G23 1047 plus 0.5 times G24. We're doing this times this to come up with this. This is for 3/4 of a year. And then what is it for 1.25 year bond? 1061. How are we doing this? 0.05 times G24 plus 0.5 G25. For 1.75 years, it's 10.74. We fill in the gaps there. Following for 1.5 years, it is understood that the discount rate for the payment at the end of 6 months is 10.469 right here. If we stretch this out, it's going to be 10.469. And the discount rate for the payment at the end of year 1 is 10.537, 10.536. You round that up. We know that the bond price 96, pricing is right here, 96. We know that the bond pricing US 96 must be the present value of all future payments received by the bondholder. Suppose the 1.50 rate is denoted by R. It follows the 4 represents the semi-annual interest payment. So if we have 4, and we've done this before, we've used this formula a couple different times. We have 4 EXP 10469. We have this 10469 plus 4 EXP 1053 plus 104. What we're doing is following the same steps as we did in the previous example. We're going 4 times, and we're just using this, this, and this to come up with this price here. You see how that works? Pretty nifty. Yep. You have to determine, are we computing price? Are we computing yield? And I showed you both. In that previous example, there was one example where we were using price and the other one we were using yield. So you can reverse this. So R is equal to log normal 85196 divided by 1.5 is equal to 10.681. Where'd the 85 come from? We got 10.681. We have this 9610. We're going to reverse this now. You can see where we used the log normal. This is going to show up somewhere. I suspect this log normal 8516 divided by 1.5 is equal to 10.681. So let's see if Excel throws a big old error. There you go, 0.85196 percentage. All you got to do is put a point there and we answered that question. There's a lot of moving parts here. Just keep that in mind. You have a price of 96. This is a zero price. You have a 96 and you have this information here, 10469. You have the zero yield. You can come up with the price. And then we have this 10681. You could use EXP 10.469 plus equals 96. That's up here, trial and error. There's a trial and error issue. It may be down here. But now let's move on. We have this 3796. Let's see if this is tied to anything. I went 4 EXP. Oh, I bet you this is the trial and error right here. B53, B48, B46. We have 4 EXP 10.469. We're back up here. We're just taking this one step at a time. So we went 469, 360, 10.536, 739. So we have B46, B48. Add those two up. So we're looking at what, the 1 year? And then we have 88603. It's going to be a log normal of 96 minus B49. So we have this 88. This is solving for the 1.5 year. The 88 is 96 minus the summation here. Then this 85 is B50, 886 divided by 104. That would be the 4%. That would be the beginning 6-month number. Then we have the 1.5 year zero rate would be log normal B51, 8519. This yield, divide this by 1.5 is 10.681. Then we have 104. And again, remember up here, we had the 104, we had the 4%. So we're using 104, EXP 1068. We're going to use this number here, and we're going to derive at the price B53, 8860, B48, 36, and 3769. What do you think of that? You're thinking, wow, that's a lot of work to come up with the numbers. You're going to need to understand how this works. You're going to have to go back and just think what we're trying to do here. This is this number right here, just for simplicity. All I did was I broke this down piece by piece to derive this number. If you take this whole thing, it's this. That's the 1.5 year. When there's gaps, you're going to have to fill in those gaps. So you may have to go back up here and look at this 3/4 of a year, or 1.5 point, or a year and a quarter, or a year and 3/4. That's just the way fixed income works. If fixed income isn't your deal, and it's not my deal. I'm equity. I'm more into equity and valuation. But at one point in time, I was looking at derivatives in every way, shape, and form. I thought, wow, that's interesting. So my experiences with this stuff, I'm just sharing with you. So solving for 2 years, we know that the discount rate for the payment at the end of 6 months is 10,469. And that the discount rate for the payment at the end of year 1 is 10.536. Why do we know that? Well, because we have it right here. We're looking at zeros. Keep that in mind. Remember, we're looking at 10.469 and 10.681. We know that's 10.536 in the payment at end of year 1.5. The payment is 10.681. We know that the bond's price is 101.6. To keep in mind here, here's the 101.6 at year 2. The question is, suppose the 2-year zero rate is denoted by R. It follows, what is the 2-year zero? We can use this formula right here. We're going to come up with 101.6. And with 101.6, we know we can derive this using this, all this stuff here with this number. Following the same steps, all I did was I broke this down. And there's no surprise here as to what we're trying to do here. This is 2 years, so we're going to have one additional row in order to accommodate that. And then we're going to come up with this 10,808. Calculation of forward rates using zero rates here. This is where it gets a little bit confusing. The question is, well, why do I need forward rates? Well, because if you need a forward price, you have to determine your forward rates using zero rates. And we discussed it up here. Remember, we were using the formula previous example I showed you, forward rates. And if you need to go back to the previous example. So we have year 1, 2, 3, 4, and 5. And we have zero rate for end period investment. This is given. You're going to hard code this in here, and it could be any number you want. You could probably put this information, well, you could put year 1 and year 2. You don't have year 3, 4, 5. You're going to have to figure out what the zero rate is. If you can't find it, then you're going to have to go up here and do this hard work. But let's just say you have the zero information. Forward rate per nth year per annum. We have 3%, 5%, 5.8, 5, 6.5. Again, that's hard coded. Here's the calculation, and we've done this before. We're going to use this 3% plus C81 plus C81 minus 0 times 0 divided by B81 to come up with 3%. You're going, well, why 0? Because it is year 1. And then we're going to go C82. And remember I said we're going to go forward then back. So we go C82, which is going to be 4%, plus C82 minus C81 times B81. Here's the years. We went B81 divided by B82 by B881. And so we have to go up 1 year. That's why we went 0 here, because we have to go back 1 year, and we have to have a 0 timeline. And then here, all we're going to do is just stair step this. And then by the time we get to year 5, we're looking at C85, 5.3%, plus C85 minus C84. Taking this minus this. Then we're going to take this B84, which is the time, divided by B85 minus B84. And we have forward rates. Forward rate for year 5, 5.3, is 6.50. And here's the formula I just worked through. And then you can verify this by 4% plus 4 minus 3 times 1 divided by 2 minus 1. And that's just verified. And then the equal zero rate is G82, So we have to go back to G82 plus G81 divided by 2. Remember I said so we're averaging the forward rates and divide them by the time. You're going to get your zero rate. So no challenge there. It's just a matter of following the steps. Compounding, this is for year 5. For 1 year, zero rate at 5.3%. Continuous compounding. You take 100 EXP, and this is for year 5. So if we want continuous compounding, it's going to be 105.44. Normal compounding, 105.30. Normal semi-annual, normal quarter compounding, and then continuous. Got that? I just repeated it. For 2 year, 0 at 5.3. Notice we took D89, taking this above, times EXP 5.3 times 1. Then we're going to take D90 times EXP 531 times 1, and so on and so forth. And here, we're going to go with normal compounding. We're going to go 100 times C85. Notice we have to go back up to C85 for normal compounding. So we're going to go back up to 5.3%. We're just going to use normal compounding. 100 times C85, 5.30. No magic there. Semi-annual compounding, all we're going to do is the same stuff over and over again. We're going to take 5.3 and divide it by 2 times 100. Then we're going to take 105.3 divided by 2 to the power of 2 times F89. F89, so 105.37. For 3 years, so we have 105.3 divided by 2 times F90. So we have to go back up 1 year in order to accumulate, because we know what the second year semi-annual compounding is. So the third year is going to be the same thing. All we're just using is the compounded interest from year 2. Quarterly compounding, we're going to do the same thing. All we're doing is divided by 5 and going up to the previous row. Now, zero rates, let's say, you remember here we have our verified zero rates, which is 4%, 4.6, 5, 530. So 0, so we took 0.3 times 4, 0.4 times 4.6, 4.6. Did I do any math here? We have this 108.33. This number right here, 108.33. We took EXP, and here we have 100 EXP 0.3. So we're going back up here to our 0.03. That would be right here. We're looking at forwards. We have the forward rate, so we're going to multiply 0.03 times 1, EXP 05.1 to get this price. So we're taking the 3 and the 5. Notice we're going to go 58503 in order to get this price. We got this price right here by 100 EXP 833. Really comes down to what information you have. If you are missing, let's say you have a price of 114.80, or no, let's say you have this forward rate. You need to figure out what that price is. You have this 114, and if you have a missing piece, now you know how to go about finding it. We have a zero rate, we have a forward rate, we're going to have zero pricing, and we're going to have forward pricing. And this 114 is 100 EXP C83 is the zero price, verified here. I'm going to go over to the right. Forward rate equals 5% for 2 years. Forward is 0.04. We're going to repeat this over and over again. So we're going to go forward 1, back 1. We went 0.4. This is for year 1. This is for 5%. We went 0.4 plus 0.4 minus 0.3 to 1 divided by 2 minus 1. So right here, we're going to use this formula. No magic. We've done it repeatedly. Here's the formula right here. So we're going to take 4 plus 4 minus 3, 4.6, 4.6 minus 4, 2, and we're going to get this forward rate using zero rates. Now we can reverse this, and we have. If we have forward rates, we know we can go back and we can figure out the zero rates. Got it? How? By just doing simple math. Now forward rates, if you didn't understand what I was trying to show, now we have forward rates, 3% times 5. Now we have EXP 3. Here's our forward rate, 3%. So now we have EXP 3 times 1, EXP 05 times 1 gives us a price, that's the forward price, of 108.33. How do we get the zero rate? We go 0.3 plus 0.5 divided by 2. Over here, you remember that? And then we have this forward. We're doing this repeatedly. Okay, here's our pricing. And then in order to get this zero rate from forwards, we're just going to take the average. To show how forward interest rates are the rates of interest implied by current zero rates for periods of time in the future. To show how they're calculated, we suppose that a particular set of zero rates are as shown in column D above to the right. The rates are assumed to be continuously compounded. Thus, the 3% per annum rate for the 1 year means that in return for an investment of US dollars 100 today, an investor receives 100 EXP equals 103.05 in year 1. 4% per annum rate for 2 years means that in return for an investment of US dollars 100 today, the investor receives 100x to the fourth second 108.33 in 2 years. You got that? To show how they are calculated, we suppose that a particular set of zero, be sure to read this carefully, zero rates, a particular set of zero rates are shown in column D above. It's this information right here. If we assume to be continuous compounding, the 3% per annum rate for 1 year would be 103.05, and for the 2 year it would be 4%, and you get 104 times 2. The forward interest rate, notice the difference between zeros and forwards. Forward interest rate listed above for year 2 is 5% per annum. This is the rate of interest that is implied by the zero rates for the period of time between the end of the first year and the end of the second year. It can be calculated for the 1 year zero interest rate of 3% per annum and the 2 year zero rate of 4% per annum. It is the rate of interest for year 2 that, when combined with the 3% per annum for year 1, is 4% overall for the 2 years. We take the 3% and the 5% to get the 4%. Confusing? Of course it is. To show that the correct number is 5% per annum, that's per annum. Keep that in mind. Remember, we have to discount this back at 3%, and then we have to discount this at 5%. What's going to be it's going to be the 4%. Let's just see how this works. To show the correct answer is 5% per annum, suppose that the US dollar is 100, invested a rate of 3% for the first year and 5% for the second year gives 100 EXP, 3 to 1 EXP equals 108.33. Where's 108.33 in terms of pricing? It's right here, 4%, 108.33. We're using that 3% and the 5%. Yeah, you're going to have to stop and think about this for a bit. We've done the math. This example shows the general results that when interest rates are continuously compounded, rates in successive periods are combined, the overall equivalent rate is simply the average rate during the whole period. In our example, remember here we went this average, 4%, 4.6, average 3.5. Everything goes full circle here. It is the average. Our example, 3% for the first year and 5% for the second year, averages 4% over the 2 year period. The result is only approximately true when the rates are not continuously compounded. The forward rate for year 3 is the rate of interest that is implied by a 4% per annum 2 year zero rate and a 4.6 per annum 3 year zero rate. It is 5.8% per annum. The reason is that an investment for 2 years at 4% per annum combined with an investment for 1 year at 5.8% per annum gives an overall average 3 year period of 4.6 per annum. The other forward rates can be calculated similarly and are shown above in column H. So in general, if R of 1 and R of 2 are the zero rates for maturities T of 1 and T and 2 respectively, And R of V is the forward interest rate for the period of time between T1 and T2. Here's the formula. It's the same formula up right here. What are we doing for zero rates for year 4? So we're going to use R1, R2, R2, R, and T1. T1 is equal to 3. T2 is equal to 4. R1 is equal to 0.046. And R2 is equal to 0.5. Forward rate for year 6 is plus 0.5 minus 0.46, 3 divided by 4 minus 3. We've done that repeatedly up here. Okay, yeah, right here. Those are our forward rates. Now we have 6.2 forward rate for year 4. Here is the formula. Now we look at this. So we have this really ugly, nasty number, but get used to it because you're going to have to use it. We're using 12.4673. The 12.4673. That must be year 5 of something. Assume that zero rates for borrowing and investing are the same, which is close to the truth for a large financial institution. An investor can lock in the forward rate for a future time period. Suppose, for example, that the zero rates are as above. If an investor borrows US 100 at 3% for 1 year and invests that money at 4% for 2 years, the result is a cash outflow of 100 and then continuous compounding. 3 times 1 is equal to 103.05 at the end of year 1, and an inflow of 100 EXP, 4 times 2 is 108 at the end of year 2. Since 108.33 is equal to 103.05 times EXP05, a return equal to the forward rate 5% is earned on US 103.05 during the second year. Think compounding of 103.05. Discounted at 3%, we have 100, and then we have 104.08 equals D162. And then what we did is we took C163 times, all we did was this continuous compounding, 103. And then we probably just discounted this back. 162 minus 103 times EXP 03 gives us $1 or 100. And then here we have, this is 4.12. What's earned on the 103.05 in year 2? It would be 104.08 times 0.04. 104 after year 1 equals 108.33. C163 times EXP of 04 is 108.33. And the answer is 528. We're looking at, right here, we're looking at 528 EXP times 3%. And here's the math, excuse some rounding errors. This is the continuous rate. This is the 2 rates, so you add them together. Here it is again, shown mathematically, 528 EXP, discounted at 0.03, 528 times whatever that compounding is. You could discount that back, and here it is, 5123. And all we did is 103 minus 103.05 divided by 103.05. And then 108.333 is just the same number as I just crunched. That's that 108.33 times EXP. 05 is that 108.33, and then 109 would be 103 times 2, and I probably was just scribbling. And then you can do this discounted at 4% and discounted at 4.6%. As I continue to say, practice, practice, practice. This is a lot of work. If you understand this, you're home free. You know, you have the zeros and you have forwards, and then you have your discounting, and then we have spot rates, and then we have the bootstrapping, and on and on and on. It's the fundamentals, but it just takes time. Brad Williams, Frugal Finance. See you soon.